Okay, once you understand what beats is, we can now go and tackle that problem. Alright, so in our problem, we have been given that there are two waves, and these waves are actually making a particle oscillate maybe with simple harmonic motion given by 3 sine 600 pi t, and y2 equals 4 sine 608 pi t. So again, these are not waves, okay? These are simple harmonic motion that's happening at the moment where we are interested in calculating the beats. So we have been asked, calculate the number of beats heard per second, so beat frequency. Okay, so let's calculate what the frequency of this guy is. We know this 600 pi is 2 pi f, simple harmonic motion, it's sine omega t, and therefore f equals 300. So that's the first frequency. The second guy will be, divide this guy 2 pi, that's going to be 304 hertz. So the beat frequency is going to be, f beats, the difference of this, that is 4 hertz. So I'm going to hear a difference of 4 hertz, and therefore I'm going to hear 4 beats in 1 second. Okay, what else is asked is we have to calculate the ratio of the maximum to the minimum intensity of the resulting wave. Now, intensity can be proved to be proportional to the amplitude squared. That's going to be the intensity of a wave. Okay? So, what's going to happen to our wave? Well, we already know from our discussion earlier that my resulting, not wave, but my resulting simple harmonic motion is going to look like this. It's going to look like this. Maximum, minimum. Okay. However, notice that the two amplitudes are not exactly the same. So the maximum amplitude is going to be 3 plus 7. So that's 7 on either side. That's going to be the maximum. And the minimum amplitude will not be 0. It will be instead 4 minus 3. It's going to be 1. Okay. That's going to be the minimum amplitude. Therefore, the maximum intensity is going to be some constant k times the maximum amplitude squared, because intensity is always proportional to the amplitude squared. In fact, we have seen this before. Do you remember what was the expression for the total energy of simple harmonic motion? If I remember correctly, the total energy of the simple harmonic motion was half m a squared times omega squared. Yeah, think of it as half mv squared, and maximum value of v is omega times a. Exactly. Alright, so that was the maximum value of the energy. So notice that the energy is proportional to the amplitude square. Can you see that? And intensity is just the energy per unit area, so that's going to be proportional to the amplitude square as well. Therefore, some constants will be involved, which will have the mass, the omegas, and everything. Sounds good. Similarly, what's going to be the minimum intensity? That's going to be the same constant k times the minimum amplitude squared. Therefore, the ratio is going to be, what you are going to hear, this ratio is going to be 49 divided by 1. So that's 49. Therefore, I max to I minimum is 49:1. Okay, so that is the solution to our problem.